Hello everyone. In this class, we are going to discuss a one-dimensional inelastic collision. So, in the previous video, we have discussed regarding the final velocity and say kinetic energy of one-dimensional elastic collision. So, now going to derive the expression for final velocity and a loss of kinetic energy in the case of one-dimensional elastic collision. So, let us consider a body, two bodies, A moving with a velocity u1 of mass m1 and another one body B moving with a velocity u2 of m2. This is regarding before collision. After collision of v1 velocity v this is after collision. So here let us consider two bodies of m1 and m2 of masses m1 and m2 before collision with a velocity u1 and u2 and moves in a same direction in straight line with the same direction. After that it collides with the body B. Before collision is at 0. It has 0 means it is velocity is 0. After collision, both the A and B moves with a common velocity v of masses m1 and m2. Now let us check about what is the velocity of two bodies, common velocity of two bodies. Now let us derive that equation. Expression for common velocity of two bodies. So here we know that the law of conservation of momentum in inelastic collision. We know that the condition in the inelastic collision means here the momentum is conserved but kinetic energy will be is not same. So here momentum is conserved from the law of conservation of energy. Momentum So here in elastic collision momentum is conserved. According to this, so momentum of law of conservation of momentum state that the momentum of a system is before collision is equal to the momentum of the system after collision. According to that statement, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. In inelastic collision, here u2 remains 0 because before collision body B is kept constant. Therefore, the initial velocity of the body B is 0. Therefore, this term completely vanishes. Therefore, m1 u1 plus 0 equals to m1 v. Here, after collision, both the bodies are moving with a common velocity. Therefore, here v1 and v2 remains v. Therefore, m1 v1 plus m1v plus m2v. Therefore, here take v is common, m1 plus m2 of v equals to m1 u1. So we need to simplify this. We get the final velocity of a one-dimensional body with a common velocity. Therefore, v equals to u1, so m1 u1 divided by m1 plus m2. This is the expression for final velocity of a body in the case of one-dimensional inelastic collision. Now we have to derive the equation for the change in kinetic energy. Expression for kinetic energy, loss of kinetic energy in the case of inelastic collision. So here in inelastic collision, momentum is conserved, but the kinetic energy is lost in the form of another energy. That is the change in kinetic energy. Loss of kinetic energy is equal to kinetic energy of the system before collision is minus kinetic energy of the system after collision. So according to this, the change in kinetic energy can be represented by delta K here of m1 u1 square, and u2 is 0, we can write directly it is 0, minus here after collision both the body A and B moves with the same velocity of masses m1 and m2, that is m1 plus m2 of v square. So now simplify this, m1 u1 square minus of m1 plus m2 into, here we know that the value of v from this equation, so substitute the value of v here, that is m1 u1 divided by m1 plus m2 whole square. Therefore 1 by 2 m1 u1 square minus 1 by 2 m1 plus m2, this is m1 u1 square u1 square divided by m1 plus m2 whole square. So now here this term get cancelled, remaining here 1 by 2, take outside common, remaining here m1 u1 square minus m1 square plus u1 square divided by m1 plus m2. So here also in the numerator, in the both term m1 u1 square is the common, take it outside. Here 1 by 2 m1 u1 square is 1 minus, remaining here 1 minus, remaining m1 divided by m1 plus m2. change in kinetic energy delta K equals to 1 by 2 m1 u1 square 1 minus m1 by m1 plus m2. So here 1 by 2 m1 u1 square of, take the LCM of these to m1 plus m2 minus m1 divided by m1 plus m2. So here minus m1 plus m1 cancel, remaining 1 by 2 m1 u1 square of m2 divided by m1 plus m2. This is the expression for change in kinetic energy. Again simplify this. m1 u1 m1 m2 u1 square divided by m1 plus m2. This is delta K, change in kinetic energy. So before collision B remains constant. The velocity, initial velocity of B before collision is u2. Therefore, according to this equation, simplify here, delta K equals to 1 by 2 m1 m2 into u1 square minus u1 square minus u2 square whole thing divided by m1 plus m2. This is regarding about the loss of kinetic energy in the case of one-dimensional inelastic collision. So kinetic energy will be lost by in this form. So this is the expression for kinetic energy and also a final velocity of a two body moving with a common velocity. So this is the diagram about a two-dimensional elastic collision. So the next topic, elastic of a collision of a two-dimensional elastic collision. So here we consider two bodies of A and B of masses m1 and m2 of initial velocity u1 and u2 are moving in the same direction, means it is along x-axis. So it is along x-axis. Before collision they are moving in the same direction. So after collision both the body will take the different direction of it create an angle. It deflected at an angle of theta 1 and theta 2 of mass m1 and m2. So here also we need to calculate what is the kinetic energy and also what is the momentum of a body in two-dimensional elastic collision. So here first we know that according to the law of conservation of momentum in conservation of two-dimensional elastic collision. So we know that according to this statement, momentum of before collision is equal to the momentum of a system of after collision. Here it is defined as the algebraic sum of x component before collision is equal to the algebraic sum of the system of in x-axis after collision. Algebraic sum of x component before collision is equal to algebraic sum of x component of after collision. Here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 u2. So this is along x component. Now let us check along y component. Similarly, along y-axis, therefore here sum of the algebraic sum of y component before collision is equal to algebraic sum of y component of after collision. Therefore in this case, in y-axis before collision is 0 because before collision the body moves along a x-axis. Therefore this is 0. Before collision is 0 equals to m1 v1 sin theta 1 plus m2 v2 of sin theta 2. So here along x-axis this cos theta 1 plus m1 v1 of sin theta 2. Cos theta 2. So this is along x-axis, this is along y-axis. So this is the law of conservation, expression for conservation of momentum of two bodies, two-dimensional inelastic collision. Before this is along x-axis, this is along y-axis. Now let us check what is the kinetic energy of this system. So here kinetic energy, according to this law of conservation of kinetic energy of a system before collision is equal to the after collision, that is of m1 u1 square plus of m2 u2 square is equal to m1 v1 square plus of m2 v2 square. So this is regarding about the expression for kinetic energy. So here after collision the body it involves four unknown quantities, that is v1 v2 and theta 1 and theta 2. These are the four terms are involved after collision. So we need to calculate among four unknown quantity. We should know about one quantity should be known. This is regarding about the collision of a two-dimensional elastic